Hello students, welcome back. I hope your Thanksgiving was good. Time for the next lesson, application of linear equations, lesson 9. So in lesson 9 we will learn how to rewrite an exponential expression that represents a series as a linear equation. Okay, series is when something happens over and over again. We're going to see that in just a second. We can rewrite equations to develop patterns and make predictions. We know that for problems like these, we can generalize equations so that we do not have to do each step in our answer. We learned how equations can be used to solve problems. All right. So let's take a look at this. Marvin paid an entrance fee of $5 plus an additional $1.25 per game at a local arcade, although he spent $26.25. Right, and saw altogether, he spent $26.25. Write and solve an equation to determine how many games Marvin played. So we got to make sure we answer the question. But let's take a look here. So what did Marvin do? He paid an entrance fee of $5. So he started with $5 plus, so that's plus an additional $1.25 per game. So that's our series. He's doing $1.25 per game. So it's $1.25 times each game. Altogether, he spent $26.25. So if I add all of the games plus the $5 entrance fee, the total was $26.25. So that's our series. He's playing a bunch of games at $1.25 a game plus the $5 he started with, and that equals $26.25. So let's see how this looks when we write it and solve it as an equation. And $5 plus $1.25 per game is $26.25. We subtract $5 on both sides. So if I subtract $5 on both sides, then I've got minus 5, and that's $1. This is gone. $26.25 minus 5 is $21.25. So it's $1.25 a game. He spent $21.25 on the games. So take away the entrance fee. He paid $21.25 on each game. Subtract by, divide by $1.25 each game. I'm having trouble with my brain. So that cancels out. So each game, he played 17 games. Okay? So write and solve an equation to determine how many games he played. So here you wrote, that's the first part. Here you solved, right? Right, solve. So I need to see both of these. And then the last part is determine how many games Marvin played. Marvin played 17 games. Okay, so 3 parts to this answer. I want all 3. Okay, neatness does not count. Just want to point that out before we get to the end where people are just writing, well, the answer is 17. The answer is not 17. The answer is Marvin played 17 games, and here's the work I did, and here's the problem I wrote. Right? So let's try this one. The sum of 4 consecutive integers is negative 26. What are the integers? So here's our series. We have 4 consecutive integers. And if you remember from early on, if the first integer is x, then the next one is x plus 1, the next one is x plus 2, x plus 3, etc. So I have 4 of those. So here's x, right? So here's the first integer, x, the second integer, x plus 1, the third integer, x plus 2, the fourth integer, x plus 3. So here's my equation. Now I'm going to simplify this a little bit by combining like terms. So x plus x plus x is 4x. These are inside parentheses, but I only put them inside parentheses so you can differentiate x plus 1 plus the terms are separate. There's nothing multiplying these, so they're basically being multiplied by 1 if you want to think about that. So 1 times x is x, 1 times 1 is 1, and parentheses are gone. So don't get confused with parentheses. Parentheses are here to make it more, so you can see more clearly the 4 terms. So I add up the 4x's, I have 4x. 1 plus 2 plus 3 is 6. Got it? Now I have my equation, 4x plus 6 equals negative 26. I'm going to subtract 6 on both sides. 4x, negative 26 plus negative 6 is negative 32. And then I'm going to divide by 4 on both sides. X equals negative 8. So the first term is negative 8. What are the integers? So I need all 4 terms. So I'm going to go here and say 8, negative 8 plus 1 is negative 7. Negative 8 plus 2 is negative 6. Negative 8 plus 3 is negative 5. So the 4 integers are negative 8, negative 7, negative 6, negative 5. Got it? All right, let's move on. Next problem. A book has X pages. How many pages in the book? If Maria read 45 pages of a book on Monday, half the book on Tuesday, and the remaining 72 on Wednesday. So I like to start this one. Monday plus a Tuesday plus a Wednesday equals the X number of pages in the book. Okay? So Monday plus Tuesday plus Wednesday equals X. Okay. On Monday, she read how many pages? She read 45 pages on Monday. On Tuesday, half the book, so half of X. And on Wednesday was 72 pages. Okay. I like to go slowly when I'm writing these equations and one step at a time so I don't make mistakes. All right. So Monday, Tuesday, Wednesday. If I add 45 and 72, I get 117. If I subtract 117 on both sides, this a 7, I have a half of X equals 117. Notice how I flipped it backwards. If you subtracted X, negative 117 on both sides, you would have negative 117 equals half of X. I can flip that around. When it's the same, I can just flip it around. It's no big deal. Now here's something you haven't noticed. If I do a half divided by a half, right? So a half divided by a half, you know that is a keep, change, and flip. And then it comes 1. And that works with anything. This is why fractions are so cool for every time you're doing this stuff. Whatever my fraction is, if I have 3/5 y and I want to make it 1, then I multiply both sides by the fraction flipped over. And I end up with 1. Okay? That's why I like fractions. I don't have to figure out what is the reciprocal that multiplies to equal 1. I don't have to think about it. I just take the fraction and flip it upside down. So a half flipped upside down is 2. If I multiply by 2 on both sides, I have X equals 117 times 2 is 234. So how many pages in the book? The book has 234 pages. Okay, so we need 1, 2, 3 for the full price, for the full credit on this answer. All right, a number is increased by 5 and divided by 2 is equal to 75. What is the number? So if I increase the number times 5 and then divide by 2, so I make this whole thing divided by 2. This could also be written without fractions like this. X plus 5 divided by 2 equals 75. Means this whole thing first has to be added and then divided by 2. So we do this as just a line because fractions are so much easier. Why are they so much easier? Because if I multiply by the denominator on both sides, this cancels out and I have x plus 5 equals 75 times 2, which is 150. Then I can subtract 5 on both sides, so x equals 145, and the number is 145. So a number increased by 5 divided by 2 is 75. So I can check this by saying 145 increased by 5 is 150. Divide by 2 is 75. Got it? All right. Okay, that's it for lesson 9. Try on your own these 5 questions. 1, 2, 3, 4, 5. The answers will be on the side. Remember, with these similar triangles, each side is a ratio. So BC is a similar ratio to AC, and AC are similar ratios, and BC and BC are similar ratios. So what we learned was equations can develop patterns and make predictions, and we know for problems like these we can generalize our equations so that we do not have to do step after step to get our answer. Like when the kid was figuring out how many games he played, you took away the $5 he paid admission, and instead of saying 1.5 times 1.25 or whatever, $1.25 per game, adding them all up to get 17, you just multiplied by 17. It was a pattern. Okay, so we know how to rewrite exponential equations that represent a series as a linear equation. All right, so that's it for lesson 9.